Okay, a little more work with slope-intercept form of the equation. We are on page, oh, the page is underneath here. Let's see. Page 13. Okay, so now we have got a scenario where they are actually asking us to write the equation. They're giving us a graph, which is good. So we're going to write the equation. I can get my pen situated. Oh, please work. We're going to actually write the equation of the line. So basically we need to know the slope and we need to know the y-intercept. So y is equal to mx plus b. That's what our format is going to look like. But we have to know what the m is and what the b is to be able to plug it in. Well, of course, the m is the slope. It's the rate of change, the rise over the run. So if we pick any 2 points on our graph, first of all, we know our slope is positive because it's rising from left to right. And if we can calculate the rise over the run. So if I pick, why don't I just pick this point right here, we rise up 2 and we run 2. So our slope is rise up 2, run 2, and our y-intercept, where does this graph intercept, take a hold of the y-axis, and it's right here. So that's negative 1, 2, 3. So if we clean this up a little bit, of course 2 over 2 is just 1, so the equation of our line is y is equal to x minus 3. Kind of cool. All right, let's go look at this next example. Again, we have to, oh, I didn't fill this in. So we have to identify the slope. It's positive. It's 2 over 2, which is 1. And our y-intercept was negative 3. We're looking at this guy, our y-intercept. Where does he cut the y-axis? At the origin, at 0. The slope, we know it's going to be negative because we're starting high and we're falling from left to right. So if we calculate the rise, it's 2, and the run is 1. So there's the slope, and now we can fill it in to y equals mx plus b form. So if I write that over here, y equals mx plus b, y equals the m is negative 2, and the b is 0. So when we clean this up, we don't have to say plus 0 on the back end. We can just say y is equal to negative 2x. Keep on keeping on. This guy, the slope and the y-intercept, I'll go find the y-intercept. He's pretty easy to spot. He's where the line goes through the y-axis. That's at 1, 2, 3, 4. And the slope, again, is going to be negative because I'm falling from left to right. Let's use these points right here. These are pretty easy. Rise over run. So the rise is 1, 2, 3, 4, 5. And it's negative. And the run is 1, 2, 3. So negative 5 over 3. The y-intercept, the b is 4, and we're ready to write the equation. So we're using the format y is equal to mx plus b. Y is equal to, and I'll just go change my colors. The m is minus 5/3. X plus the b is a positive 4. So that is my equation of the line in slope-intercept form, all the information pulled off of the graph. Now we've got a perfectly horizontal one and a perfectly vertical one. And these, as you know, are sort of the exceptions in the way we write them. So this guy, he's perfectly horizontal. If you go back to your notes, his slope is 0 because he has no rise. He does not rise up or down. So his numerator is 0, which makes the entire quotient, the entire ratio 0. Where does he intercept the y-axis? Right here at positive 2. So if we were going to write the equation, y is equal to mx plus b, we have y is equal to 0x plus 2. And of course, 0 times anything is 0. So our equation of the line becomes simply y is equal to positive 2. This last example gives a vertical graph, and it says, why can't its equation be written in slope-intercept form? So if you look at this, if you look at this line, there is no y-intercept. This graph does not ever intercept the y-axis. So for us to say y equals mx plus b, we can't fill in a b because he does not intercept the y-axis. So if you look at this, if you look at the points on this line, let's look at the 3 that are shown. This point right here is 1, 2, 3, 2, 3, 0, and 3, negative 2. Remember, a straight line has an undefined slope. So not only can we say that there is no b, there is also no slope. So this equation does not work for a perfectly vertical line. There is an equation, though, for this line, and that equation is x equals 3, which says for every y, it doesn't matter what your y coordinate is, your x coordinate is 3. X equals 3 is the equation of that line. And this is kind of a special, unique circumstance. Vertical lines and horizontal lines have their own special properties. Thanks for watching.